Lesson 4.1, identifying and graphing sequences. So one of the things we talked about is math is two things, the same thing in different ways, and also about patterns. When we talk about sequences, we are talking about patterns. That's all we're talking about. So I'm going to do this lesson a little differently. We are going to do the your turn problems within the lesson as our notes today. And then in class, we're going to do some example problems from the homework, and then you'll do the online homework. So one of the things you want to look at here are some of the different terminology. Always look for these highlighted words. We're going to talk about what an explicit rule is, and then there's another one that's referred to as a recursive rule. But being able to use tables, I'll be honest with you, I'm going to eliminate this middle section here. This is just where you work the problem out. We're going to use calculators to help us do that. So here is our first one. First two problems. Says write the first four terms of the sequence defined by the explicit rule. So all that means is we have this equation, and what we want to do is we want to find the first four terms. So what we're doing is we're looking for f of 1, f of 2, f of 3, and f of 4. Now I'm going to show you one way to do it, and I'm going to talk you through another way using the calculator. So the first way we do it is basically all we're doing is we're taking 1 and plugging it into the equation. So what it basically looks like if you work it out by hand would be this. We take 1 squared minus 5. 1 squared would be 1. 1 minus 5 would be negative 4. So that would be the value. Now, an easier and quicker way is to take the equation that they give you right here and just plug it into your calculator. So you go to y equals on your calculator, and instead of using n, you type in x squared minus 5. Then you go to your table set. You want to start at 1, since we're using 1 here for our x. You put independent and dependent both on auto. Then you go to your table. And then right there it gives you the values, and all you have to do is look at it. So when x is 2, you get negative 1. When x is 3, you get 4. When x is 4, you get 11. So that's an easy way to find the values using the calculator. That's a bad 11. Sorry about that. And again, we're going to talk about patterns as we look at these. So a pattern here, what happens? It went up 3. Went up 5, went up 7. So there's a pattern there. It keeps increasing by the next odd number, okay? But we'll talk more about that later on. So in the second one, or problem number 7 here, again, all it's wanting you to do is wanting you to find the 15th term. Now, this is why you want to use your calculator. You could do this right here and build your way all the way up. You could even just do 15 and plug it in to the equation and figure it out. The problem is the bigger this number gets, sometimes the harder the math gets here. So as long as you go in and change the equation to this, then you can find the value. But this one's not too bad. 4 times 15 is 60. 60 minus 3 is 57. So that would be 57. Okay. All right, let's go to the next one. So this one says write the first 5 terms of the sequence. Now this is using what is known as a recursive formula, and that term was on the previous page, a recursive formula. So to get the new term, you take the previous term and you do whatever here. In this case it subtracts 2. So we know what f of 1 is. So here we have f of 1 is 35. Now, to get f of 2, what I do is I take the value for f of 1, and that's what this notation right here means. Take the previous term. So if I'm looking for f of 2, then I take f of 1, and then I subtract 2. So what was f of 1? F of 1 was 35. So I do 35 minus 2, and we get 33. Then I do the next one. So to get f of 3, I take f of 2 and then subtract 2. Well, what was f of 2? 33. 33 minus 2 is 31. So f of 3 is 31. Now, again, look for patterns. We had 35, 33, 31. What's happening every time? They're going down by 2. Why? Because right here we are subtracting 2 every time. So what would f of 4 be? F of 4 would be 31 minus 2, which is 29. What would f of 5 be? 29 minus 2, which is 27. Now, here's the issue with recursive formula. You cannot do recursive formula in the calculator. Let me say that again. You cannot do recursive formula in the calculator. So that's a limitation to it. Okay, let's do problem number 11. So I'll do this one in blue. So f of 1 is 45. Look right here. What am I doing every time? I'm subtracting 4 from it. So f of 2 would be 45 minus 4, which is 41. F of 3 would be 41 minus 4, which is 37. F of 4 would be 37 minus 4, which is 33. And then f of 5 would be 33 minus 4, which is 29. So there are my first 5 terms. Okay, what about when we graph? So this says construct and graph the sequence described. A pizza place is having a special. If you order a large pizza for a regular price, $17, you can order any number of additional pizzas for $8.50. Use the recursive rule for each whole number n greater than 1. Now, the reason it says whole number greater than 1 is because you can't have a negative number of pizzas. So that's the reason we use this here. So we know f of 1 is 17. So we buy one pizza, it's $17. Then what do? Every time after that, we are adding $8.50. So if I get 2 pizzas, it's 17 plus $8.50 for the next one. So I add 17 plus $8.50. And if I do that, that gives me $25.50. Okay, now, how many of these do I need to do? Well, that's where I need to come over and look at my graph. I have 6 here. So I need to go up to 6. So I need to do this 6 times. Now again, the problem with the recursive, you can't use the calculator. So we do f of 3. So I add 850 to 25.5. So I'm going to go to 25.5 plus 8.5, and that gives me 34. Then f of 4, add 850 to that, I get 42.5. F of 5, add 850 to that, and I should get 51. Let me double check myself here. Don't want to make a mistake. Yep. And then f of 6, add another 850, and I get 59.5. Now all I do is I come over here and I graph. So f of 1 was 17. So 17 would be somewhere close to right about there. 2 is 25.5. So that's just barely above 25. That's a little off. Let's move it over a bit. Okay. 3 is 34. So 34 would be right about there. F of 4 is 42.5, which would be right there in the middle. Again, that's a little off. Sorry about that. And that's even worse. Try this again. It's a little better. And then f of 5 is 51. Well, that doesn't even show up. Okay, now what you should notice is that this is a linear function. Linear. In other words, I can draw a line going through all these points. Now, I can't use a ruler on my iPad because it messes it up, but I just freehand it. Now, one thing to note here, I'm not going to put an arrow on the end here. And the reason is because I can't have less than 0 pizzas. Okay, can't have that. And in fact, my equation should, or my line, should end right here at 1. Because if I order 0 pizzas, it's $0, which means at 1 is the first pizza I buy. So that's what my equation should look like. So let's do another one real quick. It says a gym charges $100 as the membership fee, okay, and $20 monthly fee, okay. So let's talk about this just a second. $100 membership fee. Now that's important. $100 membership fee. That is our starting value. That's our starting value. Now, we've talked about this before. We said starting value can also be referred to as starting as our zero term. That means if I went 0 months, it's still going to cost me $100 for the membership fee, but it is also our y-intercept. Now, why is that important? Because if we're using the equation y equals mx plus b, that is our b, our y-intercept. Well, you look right here, there's the plus 100. Okay, what about the $20 monthly fee? We could say that is $20 per month, even though it doesn't say the word per. What was that? That is our rate, which we also refer to as our slope. Where's our slope at? That's our m. We'll look right here. There you go. So this is an explicit rule, but it's a linear equation, and that's where that comes from. So how do you get this? Well, this one's a lot easier. You can use the table on the calculator to do this. So you go to y equals, you type in your equation, 20x plus 100, because on the calculator we use 100, or x instead of n, sorry. Go to our table set, second window. In this case, I'm going to start at 0, because this graph right here on our x starts at 0. And I'm going to put them both on auto and then press second graph, go to my table, and then there are my points. So all I'm going to do now is I'm going to plot these points. So I have 0, 100, which would be somewhere right about there. And then I have 1, 120, which would be here. Oops, I'm really bad at this. 2, 140, so I go to 2, 140, which would be right about there. 3, 160, so a little bit above that. And then 4 is 180, it should be right there. Okay, and you see the straight line. So then all I do is I connect those, and again, my points are off, and then I have to freehand here. And again, I don't put an arrow on the other end, even though we typically do in a line, because I can't have 0 months. I can't have a negative number of months. So again, we're going to do some of these homework problems in class, and then you'll have your online homework.